So in this video, I'll be talking about 10 important points regarding nanoscale science and engineering. The very first important thing that's there when it comes to the nanoscience and engineering is the size range. And nanoscale science and engineering deals with structures and phenomena at the nanometer scale, and the range of that scale is 1 to 100 nanometers. And at this very scale, materials exhibit unique properties and due to quantum effects and increased surface area. Point number two, there is certainly the involvement of quantum mechanics, as long as the transition of classical properties takes place at this very transition scale. So nanoscale phenomena are influenced by quantum mechanics, which governs the behavior of the particles at atomic and subatomic levels. And quantum effects certainly become more pronounced at nanoscale. The point number three is the surface effects. Certainly, when we go to the nano level, there is increase in the surface area of the material. At this scale, a significant portion of the material is located at the surface, leading to increased surface to volume ratio, and this result this results certainly in enhanced reactivity and unique surface properties of these materials. Point number four is it is about the size dependent properties, which is certainly linked with the quantum mechanical behavior. The properties of materials at nanoscale, like optical properties, electronic properties, magnetic properties, mechanical properties, all of these properties differ from their bulk counterparts due to the influence of size and quantum effects. The next important point is the nanofabrication techniques. Certainly, when you have the material, you have to fabricate these materials into practicality. So, nanoscale science and engineering employs various fabrication techniques, including top-down, like lithography, and bottom-up, like self-assembly approach, to create nanostructures and nanomaterials. The next important point is the nanoparticles. So nanoscale science, it certainly deals with the synthesis and characterization of nanoparticles, which are particles with dimensions in the nanometer range. So nanoparticles have applications in various fields, including medicine, electronics, and in the processes of catalysis. The point number seven is nano imaging. So here we can see that the images that are being drafted from the objects, from biological objects, organic objects, inorganic objects. So here, in case of nanoscale imaging, we have advanced microscopy techniques, and these techniques are scanning tunneling microscopy, which I have already discussed, atomic force microscopy, and these microscopes they allow scientists to visualize and manipulate nanoscale structures with high precision. And then comes the point of what we call as what comes next is the nano composites. And these nano composites are what should I say, is that we develop the materials in the form of composites. Like nanoscale engineering is involved here in this case, where nanoscale engineering involves designing and fabrication of these composites, these nano composites, which are the materials composed of matrix with embedded nanoparticles. So different kinds of nanoparticles are embedded at different sites, and we call such things as nanocomposites. Nanocomposites often exhibit enhanced mechanical properties, enhanced thermal properties, and varying electrical properties. And then comes the point number nine, and what's that? That is the nanoelectronics. So nanoscale science has revolutionized electronics by enabling the fabrication of nanoelectronic devices such as like nanotransistors and quantum dots, which can lead to a faster, smaller, and more energy efficient electronics. So this is what makes nanotechnology so important, that we can enhance the properties of materials, and we can make them as small as possible, and at the same time they are very energy efficient in the domain of electronics. The 10th point here is about the interdisciplinary nature of this nanotechnology. This nanoscience and engineering are inherently interdisciplinary, bringing together expertise from various fields. As I have mentioned it in introduction itself, like physics, material science, chemistry, engineering, biology, and medicine, to explore and exploit nanoscale phenomenon. And finally, to summarize this discussion, the nanoscience and engineering, it encompasses the study and manipulation of materials and phenomenon at the nanometer scale. The unique properties and behaviors exhibited by materials at this scale have opened up new possibilities for developing advanced technologies with applications in diverse fields.